Hello, my name is Darwin. I'm a Principal Partner Solutions Architect in GitLab Alliances. Today, I want to talk to you about how you can use GitLab's GitOps Managed DevOps environments for your developer platform. We're going to chat about the best way to build a platform is on top of an extensible platform. We'll talk a little bit about how that's true of cloud, and it's also true of building DevOps solutions on top of GitLab. We're going to talk about the solutions architecture aspects of a GitLab managed DevOps environment capability. And we'll be talking about all the things that you can do, sort of the art of the possible. But we'll also be backing that with some working environment examples. So you have two projects that you can use to deploy and to test out how this works. And then you can use those projects and the code in them to build it for whatever you want to use it for. Finally, we're going to touch on a related topic, complex environment configuration data management. Because this topic is so important to managing environments, we want to show you how that can be achieved in GitLab as well. I'm going to claim that the best way to build a platform is on top of an extensible platform. And we see this out in the market that the public cloud is the extensible hyperscaling high availability platform of choice. And we see a lot of public SaaS companies building on top of it. So some of your favorite SaaS platform solutions may indeed be based on one of these public clouds. So if we think about this in terms of building a DevOps solution, GitLab is the extensible DevSecOps platform. And sometimes we don't go deeply into how extensible it is, but we're going to do a little bit of that today. So I'm going to claim that building your developer platform on top of GitLab is the best way to accelerate that capability. I get in trouble for my long titles, so we're going to actually first unpack the title. When we talk about environments, we're talking about isolated environments, and we're talking about complete environments. So as you see environments depicted on this next diagram, just keep in mind these are isolated and they're the complete environment to run the application. We're going to be talking about DevOps environments, and this is to distinguish it from other types of environments, most especially dev environments. So developer environments are a hybrid where the developer is actually working in the environment and has some capability to run the environment and run tests, but it's not a production-like environment. So we're going to be talking about DevOps environments as in the production-like environments that you think about when you read about the 12-factor app, or when you read the Continuous Deployment book by Jez Humboldt. They're going to be lifecycle managed. So lifecycle managed means the whole lifecycle. In the case of GitOps, when we create a branch, we're going to create an environment. When we update a branch, we're going to update an environment. And we delete a branch, we're going to remove an environment. This is an important aspect of this whole scenario because a lot of organizations will go ahead and automate environment creation and maybe update, but when they don't automate environment deletion, they get a big problem on their hands. And one of the biggest problems with environment deletion is who says we can delete it and at what time is it appropriate to delete it. So we'll see how GitLab solves that problem in a few key areas. We're going to be talking about a solutions architecture perspective. So what that means is in GitLab, we have a lot of pieces and parts that we can usefully assemble to do a lot of different things. In architecture, we would call these primitives. We're going to show you how those can be assembled into a working whole. Now, it would just be sort of a thought experiment in the art of the possible if we didn't also give you working code. So as I mentioned, we've got two working code examples for you. This is around the concept of self-service for developers, and they would be using GitOps CD in order to deploy any infrastructure type. So in these working examples that I'll share with you, they do serverless framework deployment to AWS and Terraform deployment to AWS. But if you look at the infrastructure as we talk through this, it doesn't matter if it's Terraform or serverless framework, and it doesn't matter what your deployment target is. As long as you have an infrastructure as code that you can use along with your application code in order to deploy, you can recreate what I'm going to talk about for anything. We're going to be talking about hands-free environment provisioning, update and disposal for all branches. So the CI for this is designed so that anytime there's a branch, there's an environment. No one needs to get involved in deploying that. No one needs to request that. It just happens as a matter of automatic course of creating a branch. And for disposal, automatically happens for deleting a branch. In every project, you have a default branch. We're going to call ours prod. And because in this project, every branch has an environment, we would have a production environment deployed. Now, of course, when you first start developing, it's not going to be a full real production application, but once you get into production mode, then this would be our production environment. The next scenario we're going to cover has a lot to do with software development. In software development, we are going to create the capability to create new features. When a developer goes to create new functionality or a new feature in GitLab, they're always encouraged to create a merge request right away. And when they do that through GitLab, they also get a branch. And of course, in this particular project, every branch means an environment, so they get an environment. Now, why would we want to shift environments this far left to have it right inside of feature branches? The answer is simple. When developers are looking at their merge request, the findings, all the quality findings and the security findings are only for the code they've changed in their branch. So this means if there's a new vulnerability sprout up, that means they have somehow inadvertently added that vulnerability to the code. Maybe they upgrade a component or they change a setting on an API gateway or something else like that. Well, if we only get the static findings, because that's all we can do in CI, then we're going to leave all the dynamic findings that require a running copy of the app until later on a different branch. And this is where we get the resistance to address findings, is because right now in the merge request, the developer has all the parts on the workbench, so to speak. So if we have a finding that has to do with, say, the API develops a vulnerability because of a code change, if we're showing them that right after they made that change, they'll easily go in and fix it. But if we wait till it's merged to a shared branch and gone through some approvals and other things, then it's going to be much harder because now a lot of retesting has to happen. So in GitLab, we have an empowered shift left. That means we need an environment all the way in the merge request so we can get all the possible findings a developer might need to know in case they introduce some sort of finding or quality problem. When you're doing development, of course, different developers are working on different feature branches. Every feature branch is going to have an environment associated with it. These environments are isolated from one another so that they don't interfere, and the developers can work at speed and get all of their feedback into that merge request. That automated provisioning is an aspect of every branch. And then the next step will be to merge this code. Frequently, it's into a branch where we're simply trying to get all the code merged in, working together, make sure there's no vulnerabilities that are only visible when all the code changes are together. And when we do that in GitLab, we encourage you to do a merge with a delete branch. And if you remember what we said before, you delete a branch, you delete an environment. So we get automatic disposal of that environment. And this is what prevents the negative cycle of environment friction that usually goes on between developers and some sort of operations department. The normal thing that happens here is environments are hard to get. And so a developer, once they get one, they don't really delete it when they promised they would. They keep it around. And then we have more environment sprawl. So the person or group that's responsible for deploying and managing and paying for environments makes it more difficult for them to get environments. And the cycle gets worse and worse. People get longer and longer time cycles in order to get an environment. And once they get it, they don't ever want to let go of it. This completely reverses that problem. If creating an environment is as easy as creating a branch and deleting an environment is easy as deleting a branch, no one cares anymore. Environments are completely utility. So it's an important aspect of how GitLab gets rid of this environment friction and environment sprawl. I'll call this merge request lifecycle managed environments. The secret here is just that in GitLab, when you do a merge, you can do a delete branch. So it basically synchronizes the lifecycle of that branch to a merge request. And so we automatically get this capability to provide one for everyone for every piece of work they're working on and clean them up automatically when they're done with them. This relieves another important aspect of environment provisioning that we talked about earlier. When can I delete it and who says I can delete it? Well, when someone does a merge delete branch and they're aware that that's going to delete the environment, we know that they're done with the environment because they're merging their code, and because they've deleted the environment, we know that they are authorized to do away with that environment or to deprovision it. So we solve those two critical other logistical problems that also can cause a lot of friction in environment provisioning and disposal. So then when we merge forward to our next branch, say the integ branch, because every branch in this repository is going to have an environment, we get an environment. If this was already here, then it would get updated. We can continue on with additional environments, say staging here. And one thing I want to point out here is the amount of pre-production environments we have is completely just up to our procedural basis. So if we want to make it so that we have to merge forward into 5 different branches to promote into 5 different environments, All we do is create that branch and make it clear to everyone how to merge. If you absolutely had to, you could put GitLab CI commands in there that only allow certain branches to merge to certain other branches. But we can control this. So it's an aspect of being able to have as many pre-production environments as you want with no additional CI coding. In this case, we're also going to depict a temporary environment, which is created in the pipeline and destroyed after some testing is done. And then eventually we go to the final staging environment. We then eventually promote to production by merging into production. Also, by doing these environment merges, we have all the controls we normally have for coding, merge approvals, and there's all kinds of rich controls in GitLab, and I'll include a video link to another video that will talk about that. But we get all of those approvals, but GitLab also has a bunch of additional deployment functionality, which is not a standard part of merge approvals or Git. And so we have some more additional rich deployment capabilities that can also be used throughout all of these stages. So we'll call these long-lived lifecycle branches. And by long-lived, we simply mean they live as long as you want them to by deleting or not deleting the branch. It's also important to know that you can destroy and recreate any of these environments. So there are controls in GitLab to say, go ahead and destroy that environment. Now recreate it. So if you need to reset these environments to make sure they're clean and you don't have configuration rot, you can do that within the user interface. I want to point out that by deleting this environment in the pipeline, this is pipeline lifecycle environment. An environment can live for just a certain portion of the pipeline, as opposed to always having to live for an entire pipeline or an entire other lifecycle. This is all the capabilities when you're developing code, CI kind of orientation, and deploying code, CD orientation. But when I've been working at large development shops in the cloud, it's frequent that an application architect will ask for an environment just to play around in. They're going to try some experiments that are manual. They're not actually coding. So they want to actually find out what happens if I change this cloud particular setting and to see what happens. So they want an environment, and that's what we think of as a developer platform, right? They can go somewhere and request an environment. With this setup, it's pretty simple. They create a temporary branch, and because they've created a branch in this project, they automatically get an environment. So we don't have to be building a branch for the sake of changing the code. We can just create a branch in order that it creates an environment, and now we have something we can play in. Interestingly, if they find their settings manually working out, they could actually put them in that branch and then decide to merge it if it made sense. We can also check out older versions. This is another common requirement. A customer is on an older version and wants to know, can they migrate? Or they're having an operational problem and someone in ops needs to deploy a similar environment and see if there's configuration drift. By checking out an older Git tag to a new branch, you can create a temporary environment to do any kind of research that you need to from the dev or the ops side. Finally, you don't have to actually create those environments from the production branch. You could create them from anywhere. So if you're partway through a development cycle, need to take a quick cut of code that's in one of the branches and test it out, that's also possible. We'll call these experiment lifecycle managed DevOps environments. So however long that experiment needs to live is how long it can stay up. The environment could be updated. Say they're doing an experiment and they realize, oh, someone put a fix in one of these branches. I don't want to take the fix. They can just merge forward again. The environment will update. So very flexible capability to provide these kind of environments. An aspect of GitLab's environments is an auto-stop environment timeout. We actually use this on our documentation, that if I open up a merge request for documentation and it sits around too long, eventually my environment is destroyed. I can easily just redeploy it by pushing a button, but that environment's not consuming resources when I'm not using it. And of course, you could use this capability and have different timeouts for all the different levels. And of course, you wouldn't want any timeouts for production, but that capability also helps you can control costs and environment sprawl. Finally, as soon as you have an environment being created for every branch, someone's going to say, I want a branch without an environment. And so in the examples that I've built for you, if they have no-env anywhere in the branch name, then no environment's deployed. Fairly simple to do. You're not completely bound to having to have an environment for every branch if you add a little CI code. Another aspect of all of this is that GitLab has the capability to have very complicated config management through its scoped environment variables, as well as the natural way in which variables inherit down a group and project hierarchy. And I'm going to go into a few slides in just a minute to show you how capable this is. Let's say you already have a developer platform You can still leverage this simply by using APIs to call the create and delete branch capabilities. So it doesn't matter how the branch is created, it will create that environment. So if you want to front this process with an existing developer platform, then that's a pretty simple process as well. The working examples are at these URLs. And as I mentioned, if you don't use any of these technologies here, Terraform, Serverless, or AWS, you can still deploy these and get a sense for what's possible and take the CI code and use it as a pattern for whatever you want to do. We're going to take a quick look at the code here and then the resultant environments just to show you that this works. So this is the serverless example that I mentioned. And if we go down here into our jobs, we're going to look at two key jobs. There's actually three in this one because we deploy an extra serverless web UI front end so we can have easily isolated environments. But this is the one that deploys our actual API endpoint. And then this one is the one that deploys the web UI. So they work together. Now, in the case of deploying the web UI, we have this environment section. And in this environment section, there are two things going on. One is we're setting the environment with this variable. And then the second one is we're collecting the URL from the job. And that's done by sort of a little trick. We set this environment variable into what's called an env file. And then when we collect that env file as a report.env, whatever's in there becomes a pipeline variable. So you see here, I'm setting dynamic environment variable URL right here inside of this file. And when this file gets read here, it's populated, and then it's back into this URL parameter here, which populates back into our UI. The other little trick is when it's time to destroy this, we have this on-stop destroy environment. And so that's pointing at another job in the same file, which is this destroy job. So in many cases, you'll only need two jobs in order to accomplish all of the environment support that we're talking about here. We'll go into our repository where this CI file is, and we have two merge requests, just like in our slides. And if we go down to operate environments, we can see that we have two environments for that same exact set of merge requests. When we pop this open, we get details about the last commit deployed, who triggered it, how long ago, what's the commit ID. So a lot of good information. Over here, you see a stop button in all these environments. Only maintainers and up have the stop button. So because I have high permissions, I have a stop button. Not everyone would have that. And the play button is how we reset the environment. So you'd hit stop and then play, and you'd reset an environment if you needed to. The open button takes us to the actual application. So you can see here we're in environment stage. And then if we hit the feature one, here we go for the environment for feature one. So each one of these has its own independent, isolated environment. Let's look what's going on in the cloud here. We're deploying a function for the UI and one for the API for each of these. So the hello ones are all the APIs and the web UIs are all the web front ends. And so you can see that for each of the branches, we have a deployed environment. So we have 6 of each here. And then I just want to take you to look at the branches in the repository to see one more thing that we talked about. If we say show all branches, we see 7 branches here. And one of them has that no env text in it. So this branch did not create an environment because we purposely created it so that it would not. So that's sort of a really quick view that these features actually work with the working example code, a little bit about the CI, and some of the environments that you can see here. I'm now going to dive into the variables model in GitLab. It's quite capable and involved. I'm going to go through it fairly quickly just so that you can see that there's some rich capability here. The real focus today was to try to help you see that GitLab's environment capability is very rich and can service your developer platform needs very well. So with CI variables, you have the ability, if you're on self-managed, to set variables at the instance level. We also have the ability to set them at all project levels. So this is depicting 3 projects in a hierarchical relationship. So the European continent is inside payment services, inside dog walking. And then inside of projects, we can also set CI variables. And this may be the most familiar place you've been setting variables in the past. As we go through this, the convergence of the configuration data is downward. So anything closer to the repository level overrides anything farther away. So it's not a policy hierarchy where whatever is set at the highest overrides anything else. It is a convergence hierarchy. So whatever's closest to the resource that has an override will be taken. And that's typical of configuration data convergence models of Chef, Puppet, etc. If at the instance level we set a variable and we don't set it anywhere else, then the net result in these two repositories will be that that instance variable is set to what it's set at the instance level. If we have another instance variable, but we set it at a group level, then the net result will be that group result. So it gets overwritten. S1 equals 1 gets overwritten by S1 equals A, and therefore the net resultant value will be A in these repositories. If we have something only at the group level, that's fine too. And in this case, we're depicting it being overridden by a subgroup and then nothing in the third group, the purple group. So then it ends up being that value. We can also override at the repository level. So S2 equals D on the France repo is showing us that we could only be overriding in one repo out of many in this hierarchy. Finally, if we set one at this level and it's set at the group level, and also set at this interim group level, then the interim group level is going to be what wins. If we set something at the payment service level and don't set it anywhere else, then that's what's going to be what wins. And then finally, if we set something at the bottom group level, then that is going to be what's taken. So it's full convergence hierarchy capabilities. You should also be aware that we can just set variables directly in repositories. We may not have any precedence at all. We're just setting them directly there. Now, this is just the CI variables in GitLab's UI. You should search our documentation for something called variable precedence, and you'll see that other things like variables set in the pipeline or variables pushed in with an API call to a pipeline have additional precedence. But if you're just trying to use the group hierarchy to set precedence for the configuration data, this would be one thing that's in your toolkit, so to speak. Also, just to note that other random repositories placed throughout the structure can also be there. You're not limited to repositories only in the bottom group level. So they would have the net combination of whatever's going on with variables that's visible and available to them. Okay, so that's one rich capability: environment variable hierarchy and convergence of the inheritance of those variables. There's a second thing that a lot of folks miss, and it's easy to miss, is that every time you set a variable, it can have an environment scope, and you simply type in the scope or pick an existing one. So when we're in a repository and we have branches, let's say, and we have a variable that we're setting, then we'll have a scope expression. By default, it's always all environments. So if you've never paid attention to this, you just might think that our CI/CD variables, when you set them, you just set them and they're set for the same for everything in the repository. Well, in reality, we can set the scope expression and it can take wildcards. So I put three more things on the screen. The scope expression S star means that any environment that starts with S will get the values in there. The scope expression prod will limit itself to the production environment, and the scope expression stage 1 will limit itself to stage 1. And we have the same issue that the most specific is what ends up winning. So if we set Z1 equals 1 at the all environments level and nothing else is set anywhere, then that is going to be what's inherited all throughout. If, however, we set Z2 equals 1, but in this scope S star, we set it to 2, then in the two branches that qualify with S star, it will be set to 2. Then in addition, if we have a variable Z3 and we set it to a different value at this level, but also another value at this level, then just for the stage 1 branch, it will be set to 3. So that's, and then over here, if we have this Z3 set to 9 for production, then that's going to be set for production. In all of this, we're talking about branches equal environments. Technically in GitLab, branches don't have to equal environments. You could set environments to anything you want. However, for the model that I talked about in the first slide, we want to set it to branch to keep things simple and easy and very GitOps oriented. And so that's just another aspect of environments here. Depicting one more scenario, y equals 3, only set for prod, then it's only going to be set in that one context. Finally, you can combine these two concepts. So the whole CI/CD variable inheritance plus environment scoping can get pretty complicated. We do show you a rendered view inside of projects, which I'm going to show you just here in a minute. Anytime you have this level of primitives available to you, you always want to design everything to be as simple as possible. And even if you can change some processes to eliminate a few other options to make things simpler, that's great. But GitLab does have rich functionality for whenever you need more sophisticated elements in order to create the kind of configuration data setup that you need. So this is at the bottom of a deep group hierarchy, which is visible here, and this is a public project. But we see here we have a global variable. It's defaulting to all environments, and it's set right inside of this project. Here's one set to S star. So right here in this project, we are setting something so it targets every environment that starts with S. We have a staged and sandbox environment, so this would override this one. And then we have all default for a bunch of them, and then additional ones set to certain values. And then here we show our inheritance. So these are variables we're inheriting from levels above us, and we can see what that level is. All right, you can see my social handles here on the screen. I want to leave you with a few resources. So we talked about some working code tutorials, and this has both working code in it as well as tutorials to step you through a lot more interesting details. Now, I'm going to say it again. It doesn't matter if you're not using Terraform, Serverless Framework, or AWS. The same structure will apply. So if you play with these, get familiar with the code, you'll start to understand the flow and how to get all of this to work together as you've seen it demoed here. 3 slides that we talked about with regard to configuration variables are from a longer video called Complex Configuration Management Monster. And there's also a working example with that as well. So if you want to take a look at that, that's at this URL. And then another really helpful thing is the solutions architecture parts list for workflow control for CI and GitOps to deploy. So when you go through this information, it tells you about the many security controls we have around all this and the deployment controls. So there's a whole bunch of things you can do to make sure that deployments are only going forward to environments when they are fully qualified by the right people at the right stage at the right time. And of course, that affects production more than some of the other environments. So that can be found here. You now have an idea of how GitLab's GitOps managed DevOps environments can help you with your developer platform needs.